All right, we're going to talk about these two special right triangles that everybody needs to know about, and you need to have an idea of what they're like to be able to do anything with your trig. So let's take a look at these two right triangles. The first one is pretty simple. He's going to be isosceles. So isosceles means what again? Two sides are the same. I wrote him this way. It doesn't matter which way you draw him, where you draw the right angle. It doesn't matter much, but this will be our right angle. And since these two sides are going to be the same length, then this will be a 45, and this will be a 45-degree angle. And if you are talking about radians, if you know about radians already, then you know that this is a pi over 4 in radians. Okay? So as we look at this one, let's just take a look. If we know that these two sides are the same length, then how do I know that in this triangle? Well, if you're opposite the same size angle, then these sides have to be the same. That's something that you probably know from geometry. So if I call this side 1, let's just say that this side is length 1, that would mean that this side has to be length 1. And hopefully everybody knows that, a squared plus b squared is equal to c squared. That's our Pythagorean theorem, where this is the hypotenuse, of course. So if this is the hypotenuse, then this is 1 squared plus 1 squared, the square root of that. So this is the square root of 2. So it doesn't matter how big I make these sides, they're always going to be in this relationship. So if I make a similar triangle, meaning it has the same size angles, but the side lengths aren't necessarily the same. So if this is a 45-degree angle and this is a 45-degree angle, or in other words, pi over 4, which we're going to start using pretty much exclusively after a little while. This guy, if I make this a 7, then I know that this one has to be a 7. And one way we could do it is 7 squared plus 7 squared, right? We could think about it that way. Or, since I know that these sides are 7 times as big as their corresponding sides, then this side has to be 7 times as big also. So that's going to be 7 root 2. So they're always going to be in this relationship, 1 root 2. Some people call it x root 2. I've seen, people think about it both ways. So again, like I said, if you wanted to think about it just sort of abstractly, if this is 45, and this is, well, we could use x, it doesn't matter. This is x, then this one's always going to be root 2, multiple of root 2 bigger than that. So they're always going to be in this relationship. Okay, so that's one of our special right triangles that you absolutely need to know to be successful. Now the next one that you absolutely must know is this guy. All right, so actually let's start by drawing this time an equilateral triangle. So what's the difference between isosceles and equilateral? In an equilateral, they're all the same size. So we'll call this one a 60, and I know that these are all 60s. If this is equilateral, it means it's also equiangular. And everybody knows that there are 180 degrees in the interior of a triangle. So we know that each of those has to be 60 if they're all going to be the same. Okay. Now what I'm going to do is I'm going to drop down this altitude here. And since this is a regular triangle, it's equilateral, equiangular, then this is actually bisecting the bottom. Now that wouldn't be true if this were any other kind of triangle other than equiangular, or like at least isosceles where these two are the same. But it only works for those kinds of triangles. Not every triangle means that when you bring down a height that the bottom is cut in half, but in this case it is. Okay, so we'll call this one the height. Let's give this side length the length. Well, actually, now let's take a look. Let's do it this way. So hopefully you can see now I've created a right triangle, and this is the right triangle that I'm concerned with. So this guy is going to be a 30 degrees. Since, again, this is a regular or an equilateral, equiangular triangle, that this is actually bisecting the angle and the side length. Okay, so if we're talking about this length, again, let's call it a 1. If I call that side 1, well, I know since this is a bisector, right? Then this also has to be a 1. So if this is a 1, then we know actually how big this is because it's the same length as this one, right? So this side must be a 2 based on the fact that, this is a 1 and this is a 1. I could have called it any number I want, but I chose to say, let's call it 1, a length of 1. And then so this had to be a length of 2 because they have to be the same, and then or twice as big, right? So whatever you call this. So again, you could have done it with an x. If I call this x and this x, then this would have been a 2x, right? Doesn't matter how you label it, really. Okay, and so this last side now, we can figure out using Pythagorean theorem again, right? That one is going to be, this time this is the hypotenuse, so it's actually going to be, this is true, but this is also true. So this is the one we're going to use over here, right? So we're going to be saying c squared, so 2 squared minus 1 squared, and then to get the square root of the square root, we're going to square root it. So this one is actually going to be 4 minus 1. This one's going to be root 3. So over here, if you were thinking about it this way, this would be a x root 3, this side. So they're always going to be in this relationship whenever you have a 30-60 right triangle. So I'll just draw it this way this time. Let's make this 30. I know that in my triangles, they all kind of look the same length. Obviously, this angle would be smaller in reality. I don't always draw them to scale because I label them. That's why I label them. I just draw them because it's something to write on. And in math, you should always be thinking about writing. And again, if you know your radians, this is pi over 6 and this is pi over 3. But the radians will be in another video if you need a review of those. So again, the side opposite the little one we usually call 1, but you can call it anything else you want, or an x, you can call it anything else you want. If I call it an 8, what happens here is that all the other sides also have to be 8 times as big because they're similar triangles, so they have to be proportional since they have the same size angles. So the side angle of the 60 is usually a root 3 or an x root 3. So that means that this is going to be 8 root 3. And this is usually twice as big, or always twice as big as this. So I know that this side is a 16. Okay, so this is how you're going to be using your similar triangles. You need to know this basic one. So everybody should have these committed to memory. So this is a 1 root 3, 2. And our 45, 45 is the other one that you should have. You should know those relationships between the sides, even though you could recreate them if you forget, but you should have them pretty solid in your brain so that you can use them pretty quickly because we're going to be using them a lot.